So in this video, I'm going to be explaining a bug that I found in my program and what I've learned from it. So I am implementing quicksort in C and ran into an error where after I partition my array and try to print out each partition, it was resulting in a seg fault. I couldn't print out the array for some reason. And so I use the GNU debugger to try to figure out the issue, and I believe I found it. So let's run over this code first. So I have quicksort here. It has the initial values. So we have the size of the partitions, which all start out at 0, and the partitions themselves, which are null. And then we put them into the partition function, which gets the pivot and compares each value in the original array, and depending on the comparison, we'll put them in the appropriate partition, and so forth. So this append function just adds it to the end of the list. The key thing to note is that these partitions are pointers to double. You can also think of it as an array of doubles. And so partition accepts a pointer to the array, and then when it appends, it will pass in a reference to the array. So append accepts a pointer to a double pointer. And so the reason why I have a pointer to a double pointer is so that these changes persist. So after the call to append, less will contain the appended element and not just be the original list after the call. So why is it resulting in seg fault if I'm passing in double array, right? Because I pass in the double array and then append changes it. So after this, it should end up with the appended element. But it's actually not, and we'll see why. So here I ran the GNU debugger. I'll just go over it line by line. So I compiled it and then called it with these arguments 1, 2, 3. And so I'm going to set a breakpoint here at line 31. So right before we enter partition. Line 45, right when we entered partition, but haven't run anything. And then line 56, when we, or after we append the value. So we run the code, and then we stop at the first breakpoint, which is right here, before we start partitioning. And so you can see that the equals array has a value of 0, which is right, it's null. And then the address of this equal is this address right here. So we continue, and then we enter partition. And we see, okay, equals is still null. However, the address of it is completely different. So that's not right. It should end up with the same address. If we continue, after we run append and print equal, print the address of equal, it's the same one as if we entered partition. And then we continue, and now we have entered seg fault. So I don't believe I can print out equals anymore, but from previous runs, equals and the address of equal actually equal right here, as if we hadn't run partition at all. So at line 30 and line 34 of execution, it's the same address, but in partition, it's the completely different address. And so the answer why is because they are two completely different variables. So this Stack Overflow thread explains it all, I kind of ignore the questions and just look at the answers. So here they said that there's two variables named p, one in deallocate and one in add memory. While they might point to the same memory location, they are two different variables, so they have different addresses. And this is kind of what's happening here, right? So we have a double pointer to equal, or called equal. However, their addresses, the double pointer, are completely different addresses because they are in different functions. So if we think about it in terms of pass by value, we are passing the value of equals to partition. However, we're not passing a reference of equals, so we're not passing the actual address. And so to fix this, I would need to change this to a double pointer. But yeah, this is the bug. I'm kind of making this video in case in the future I forget about this and look back. But yes, good thing to note, and definitely learned a lot about pointers from this project.